Hey, hello, hi, welcome to Mindbox Talks. So it's a new episode on MLOps. So last time we have discussed about few basic questions like what students are expecting from this program, and we also had a discussion on what MLOps is, and we had a few discussions on student side also, like what the program and how they going to be getting from this program, and also they have few other questions which we have already discussed in the first episode. So I request everyone to get watch that episode first getting into this episode. And this episode, we are going to jump little into the technical part and let's dive into it. So here is our tutor. So let's get started with this. Okay. Yeah.
Yeah, brother.
So
Let's.
now coming to the question part, like MLOps in action. So what are the biggest challenges companies face when using MLOps?
Right. So many challenges actually. I mean, just like somebody, if they worked on DevOps, I mean, they might know the role is not specific to one point. It's actually spread across various domains and various stuff. So a same kind of issues will come when it comes to MLOps, but only a little bit more challenges. So one of them is obviously the data, managing the data that is used for model training. So you need data snapshots to be created, and that is one part that needs to be managed. And apart from that, you also need to have a proper environment to do the development. So one problem that machine learning has is that you need much bigger machines than the normal laptops to do the development, right? So many
Yes.
complicated models, especially when you want to do some production mirroring, to do some fine tuning and testing. They runs on high-end machines. Sometimes you need GPU machines to run these models. So probably it's preferred. GPU machines are available on the cloud, but most companies, what they are doing, they also set up an internal room, a server room within their office where they purchase these high-end machines that the developer can use for doing the local development and most of the testing, even mirroring the production environment to your local. So that is one challenge that needs to be done. Most of the companies does that. Actually, that would reduce a lot of money. If you try to run these development machines in the cloud, it's going to cost you a lot. And giving control to the GPU machines to the developer could also result in a lot of unexpected cost. By accident, somebody didn't turn off the machine, it would charge you on an hourly basis. And also that's one challenge. And then you need to have a proper CI/CD mechanism. There are a lot of things that need to be tracked. You need to track the data, track the features, track the model, and track the packages, versions them. So these tracking should be well defined, and you must have a well defined process to track the stuffs. And there has to be a proper deployment practices. You need a hybrid mode. Sometimes you need a local infrastructure and also need infrastructure in the cloud for deploying the production. So then you have the responsibility to manage the cloud in a more efficient way. Another thing is that cost management, which is actually a much bigger issue, especially when it comes to machine learning. You want to make sure that you don't use the resources only when you need them and shut them off when you don't need them, and also make sure that you continuously monitor everything to make sure that you are not overusing any resources at any time. And then a lot of legal compliance issues comes in when it comes to machine learning, right? You deal with a lot of data and where this data come from, right? Do you actually have permission to use that data to train your model? So these kind of problems comes a lot, right? Especially legal issues, and you want to have the right compliances in place if you want customer trust and everything. And then the security is another big challenge, right? So when it comes to data, when it comes to the model, when it comes to various parameters that you use, there has to be a good layer of security that should be in place. And yeah, these are major challenges that you MLOps engineer has to overcome, right? And to efficiently manage the machine learnings. Exactly. So the data which is used for training must be a data that you have full authorization on. So the data that is coming from the customer should not be used for training. I mean, policies, most of the companies, including Gemini and most of the AI tools out there, they have the policies to protect their customer data. And most companies are not expected to use that data for their training. And most of the giants, not today they might be following the best practices. I mean, they had a real tough time categorizing the data. What is the data that they can use and what is the data that they cannot use, especially in the beginning stages, even as the startups face that issue. So it's important that whatever we promise to the customer, I mean, if you want the customer confidence to increase, avoid the data that comes from the customer and make sure that whatever data that is used for training, and it can come. So basically, you can have a bunch of customer you have a contract with, and you inform the customer, or you probably have a big team, the testing team, who has the ability to generate a lot of data that is used for training, and even they can use AI for that. So whatever data that are used for training your models, it is important that the company should take necessary measures that they don't get into any legal issues or compliance issues. That's important.
Even DeepSeek and ChatGPT also in the same format, right? Like they'll
They
be
don't take customer data for training their model. What they claim to do is, they actually take the data from other places and use them for their model training.
so like how do you take a model from a Jupyter notebook to production?
From development to production, how a
Exactly.
model basically, yeah. So it's a process, I mean, which is as complicated as it is. You need to have the data. So typically there would be model, there would be data, and there would be various hyperparameters that are used in the training. So you need to make sure that you track them all and you package them, right? Typically before you take the code from developer to production. And it is important that you have one place, one source of truth. It could be Git. Most companies uses Git are their version control. So you not only track your model or the code, but also track your data in Git. I mean, it does not literally mean the entire data to be stored in Git. There are various tools and technologies available which allows you to take snapshots of the data and store it in a different cloud storage like S3 or something. But that metadata, every time you take a snapshot of the data, that metadata can be stored in Git. So Git can still act like the single source of truth when it comes to the code, and also when it comes to the data, and also the other parameter that are used for fine tuning your model. So first of all, you need to have one place where you store everything. And then you want to package your model into executable artifact. Typically, before you serve your model to your customer, you want to make sure that it's not executable format, so that you can run it on a server. It could be in the cloud or it could be in a container. It should get converted to a executable form or in an artifact form, and you must version it, and along with tracking where this artifact came from, which particular version of the model, which particular snapshot of the data this model came from. You need to do some tracking so that it won't become a problem later. And then many companies prefer to use containers to serve their model because we have Kubernetes. If you are using containers, there are a lot of things Kubernetes has a lot of extensions available today that would effectively help you manage these machine learning deployments and many other complications like service mesh and other stuff. And many companies, after they build these artifacts, of course, they have to do a lot of testing. Different testing needs to happen. Typically, it can happen either on an internal server, or it can happen on a server that is mirrored from production. Once the testing is completed, you might want to containerize it, build a container image like a Docker image, store it in a registry, then deploy it to your infrastructure, whether it is Kubernetes or some other infrastructure that you have. You should have some deployment strategy to make sure that the code travel all the way to production. There should be deployment could also be a bit complicated process because you want probably some A to B testing to be done, or maybe you want to deploy partially to a small set of customers first, and eventually, if everything works well and feedbacks are great, you can actually go 100% deployment. So the process is there. There has to be a streamlined process to take the code from a developer laptop on the way to production. There must be a streamlined process. There should be a CI/CD pipeline, and yeah, that's how. Yeah.
What's the best way to keep models up to date and performing very well on over the time?
So over the time, it's a big challenge. Basically, once you deployed a model to production and your customer starts to use it, the user starts to use it, it can develop the accuracy problems over time. And that's because the data could get outdated, or the new data, when a new set of data comes, maybe the performance of the model can degrade. So this kind of issues typically happens over time. A company must have, first of all, they must have a proper active monitoring strategy. Once the model is in production, you continuously monitor the performance of the model, and also along with all other matrices that you need in a production environment. Then you should also have a scheduled testing using some new data set, maybe once in a week, or depending on the company's requirement, they should have a scheduled testing in production where they provide a set of data set and measure the accuracy for themselves. Once in a week would be a good interval which they can do that, and then measure the accuracy, and based on the problems what they find, if they find performance being degraded, it's time that they rework on the model and retrain the model using the new data sets. And that is another thing that we can do. And then it is important that a company should have a proper CI/CD practices that they do, so that they can actually continuously deploy the model. So basically, if you have the ability to deploy the model continuously, this problem can be eliminated to a great extent, because you are not deploying the model once in every 6 months. You are actually deploying it once in every few weeks. And if there is a correction that you need to do, and it can be deployed within a matter of days, that's something you must have a proper CI/CD practice in place within the company that actually allows you to continuously change the model based on the requirement. And then, yeah, I think more or less these are the main strategies a company must follow to make sure that the model performance degrade over time, to avoid those issues. There's some practices that can be followed.
Even for the big companies like Uber and Netflix also manages the same way for the thousands of models.
Yeah, they are deploying thousands of model because they have the ability to do so. Their internal infrastructure supports them. Actually, the companies like Netflix, they have their internal development platform. Even Uber has something called, I forgot its name. So basically, the companies already have their internal development platform, which actually more or less allows the developer to do most of the model development, fine tuning, and the CI/CD practices all by themselves. So the developer can do the coding, and then tracking, then CI/CD pipelines, pipeline building, even the deployments can be automated. Companies like Netflix, they use AWS infrastructure for running their applications, so they can use the infrastructure and scalability and elasticity provided by AWS in order to scale their resources. Even Uber has their own big data center, private data center, and they also use cloud to manage. Recently, they are, so to manage their own model deployment and stuff, they use service mesh to do it deployment, like green deployment, you can say. So those companies are doing much better compared to the companies who start with MLflow. But again, once the MLOps got streamlined, I believe many companies would get the opportunity to develop similar internal developer platforms. That's what we need in the future, like a few years. And Netflix already has open sourced their platform. Actually, whatever internal development platform they have built, they have already open sourced it. And similarly, many such platforms would come in, and the companies would get opportunities to develop a lot of models at the same time and scale them continuously. Yes, it takes a lot of effort from the infrastructure side, from the internal team side. Platform teams has to be working very well with the developer, understand the developer requirement. Yeah, it's not an easy thing they did, but yeah, there are companies who are doing excellent when it comes to the model development and delivery.
So like same like approaching for ML pipelines. So is it the microservices or the monolithic approach is better? Like which approach is more better to approach the
depends
ML
on the
pipeline?
company. So basically, it could be both are good approaches when it comes, just like the software development. Let's say you are developing a model that would help everyone. I mean, think about a Gemini or ChatGPT like model. They are supposed to answer any kind of queries from the user. So, and let's, depending on the requirement. So if you are building such a complicated model, it's best advised that you split the model into small models and design things in such a way that you don't have one big piece of software that is kind of very difficult to scale and manage and deploy, or right, many things. But there would be situations where you might want to consider building a monolithic applications. Even you're developing a model, for example, you are developing an internal platform specifically for your internal team. So you have mainly sales and marketing. And in that situations, you probably don't have to split the model, but rather build one model that is monolithic that can serve everyone. You don't expect these issues like deployment issues are not a big deal, or you are not expecting this model to be used by thousands of people, right? Scalability is not a big problem. So there would be situations where you keep things simple, keep things monolithic, and there would be situations where you might want to consider reducing the complexity of building one single model that support many uses. So consider the situation: there are doctors, there are marketing team, sales team, then there are doctor assistants, and different people using the same model. And there are 10 to 15 sets of stakeholders using the same model. So probably you can always find out the workflow or the kind of context within the entire business context, and then split the context into, like, let's say for doctor can use one model, and then the sales and marketing team probably can use a different one, because there is not much conflict in between them. So you don't do a lot of rework, because what a doctor wants is not something that a marketing team wants. Probably you can keep those things separated, and if the complexity reduction is one of your primary concerns. So it vary from use case to use case, business to business, but both approaches are good and fits. It just has to fit to your requirement. That's important.
And how do you know when a model performance is dropping?
Through continuous monitoring, like we said, right? Basically, you need to make sure that you should use new data sets to monitor your model. And so every time, if you are using the old data set that was outdated, and probably the model would give excellent result. But the thing is that data change over time. So 6 months back, things were different, and today things were different. The kind of data that is being generated today is different than the one that got generated 6 months before. So it is important that the companies maintain a scheduled testing evaluation of the model. Like, I think more or less the same answer I gave you to the previous question.
Exactly.
So
Previous.
proactive monitoring, and also scheduled data set evaluations, and having good infrastructure and ability to continuously take things to production would eliminate that gap.
So when should you retain a model versus fine tuning?
So most of the time, so basically model development is not a one-time process. I mean, if you think about ChatGPT, or if you think about Gemini, or any software that is out there, they don't stop the development after they delivered it first time. They keep on improving it. So that was the case in the software development, and that would be the same case in the model development. So most companies, like 99% softwares or models that you develop, you don't have a chance to retain that over long period of time, right? You just have to keep on updating it continuously to keep it fit and keep it answering to the customers in the right manner. So there would be rare situations where you want to retain a model. For example, you are developing an internal platform specifically for a specific use case. Take any example, like you want to construct a building, and let's say there are different people involved in the building constructions, and that's the business a company do. And after this project is completed, they move on to the next project, and they do all the same job. And a lot of things don't change when it comes to construction, at least not very quickly. So in those situations, I mean, a lot of data don't change. Assume the company want to build an internal a platform that would answer to everyone working in the construction, right? It could be a labor, or it could be one supervisor, or it could be the ONAs or management, marketing team, sales team, right? The kind of data that it won't change much over time, right? So where do you take the supply from? Or right, people want to ask a lot of questions, right? How to construct this particular, how many inch has to be the belt, or what kind of materials to purchase for the bathroom, or what kind of materials to purchase for the windows, and where these raw materials come from. So those questions, more or less, they don't change. The situations where, you don't see a lot of data change, data set don't change over a very long period of time, probably model development could be a one-time job. You develop it, use it forever, or maybe maintain it slightly if there is a slight data change, a vendor changed, or maybe a few changes can still happen in the construction sites. But yeah, more or less, this is the idea. So the chances are very less that you get to keep a model for long years without changing it. Chances are very less.
So how do you test models before redeploying?
So before deploying, first of all, the test should be automated, and there has to be a different type of test, right, that needs to done. So there can be unit test, basically every function that is written on your Python program, or assuming that you're using Python. So there has to be some unit testing that you can do using PyTest or unit test libraries. You can do some unit testing, and there has to be some kind of integration testing. Usually when you develop a model, there would be multiple components that would be contributing to, you give a user data, and until you get an output, there would be multiple components that are involved in that process, in that workflow. There has to be some integration testing that has to happen. And then there must be some kind of regression testing. Basically, before you go to production, you want to make sure that you compare the new model with the old model. You provide the same data to both models and see their performance difference and everything. Make sure that it don't degrade, or right, it should only improve, it should not degrade. And there would be other kind of testing you want to, for doing testing like regression, you might want to mirror your production environment, and then you want to probably do a testing on a set of machines before you go to production. And also when you go to production, it's always better to do some A to B testing. Basically, instead of deploying it to the entire customer at one shot, you can deploy it to like 0.1% of your customer, the new model. So like out of 1,000 customer, every 1,000 customer, one customer would be using the new model. The other customers would be using the old model. So if there is an issue, those 0.1% of the customer would report them, and you will get to know about the problem. You can fix them and you can correct them, and then gradually you can increase it. First you deploy 0.1% of the customer, then you can increase that to 0.5%, then maybe 1%, 5%, and then 100%. So a gradual deployment process would also help you do the testing in a more production way, how the users are actually going to use it. And another option in machine learning, what we have, you can actually mirror your production, and whatever your user is asking, you can give the question to both the models. And you don't display the output to the user. The new model that you're deploying, new version that you're deploying, it will take input from the user and it will produce the output, but it won't display to the end user. It will display only to you. So you can do that kind of testing also before confirming that everything is working well before you could deploy to the production. So there are various testing strategies that are available that one can bring in before they deploy their model to production.
So like what parts of ML pipeline should be automated?
ML pipeline should typically, you can use tools such as GitHub Actions or Jenkins. There has to be a pipeline tools. There has to be, first of all, before we move on to automated pipelines, we want to make sure that we have everything in place. We have the right team collaboration in place, and we have the right tools that can actually automate the stuff. So basically, sometimes the QA engineer is doing the testing manually. You should find an approach to bring in some technologies that can convert all the manual work into automated. Probably you should make sure that you use Git-like tools as single source of truth. Unless you do that, it is very difficult to create a pipeline. So there has to be a good team collaboration. So you need to identify what exactly the challenges what you are facing, and then identify the steps that you follow to take your model all the way to production. Then wherever we are lacking the automation criteria, for example, you are manually versioning every artifact before going to production, find a way to automate it. Or you are doing a lot of manual testing, find ways to automate it. What can be automated, make sure that it's automated. And then once we listed out those workflows and the items within that workflow, we can use tools like Jenkins or GitHub Actions, whatever available tools that we use in DevOps, similar tools we can use for automating the whole pipeline process. There are machine learning specific tools also that can do little bit extra, like data tracking and many other things. But typically, you just need a pipelining tool to help you build these pipelines. And many other things, like I said, the team collaborations and individual teams automations and stuff should be checklisted before.
So what are the best ways to reduce the cost of ML workloads?
So typically, machine learning is typically costly. Not just the workflows. I mean, machine learning. I hope the question came from how can we manage the cost.
Exactly.
So it's the typical things would be, I mean, you have a proactive monitoring of all your resources, make sure that how much you are using, and adjust your resource usage and adjust your infrastructure based on your requirement. Don't overuse. So what that means is, if you want to avoid overusage, you must have a clear observability on your infrastructure, how much your machine learnings are performing, how much CPU memory they are consuming, and what are the spikes that are happening. And those spikes, could it be managed using some auto scaling like process, rather than keeping those big CPUs for just to manage those spikes all 24 hours. It's a bad idea. So figure out how your models are performing. For that, you first of all need to have some fine observability in place, tools like graphical tools, Grafana or Prometheus, or different observability solutions to be used to have a clear understanding on what exactly do you need. And then adjust your infrastructure, CPU memory, and the machines. And whenever there's a need to run a high load, rely on services such as auto scaling and stuff. Then also make sure that you have a clear monitoring on the application performance also. Like any memory leak can lead into higher CPU and memory usages. So you should have some performance testing every time you deploy your applications to production. Make sure that a performance testing is performed and it is compared with the existing model that users are using. And if it is using unexpectedly more, then probably you should fix the problem before you go to production, so that a decent amount of CPU and memory are actually used. And many companies also set up their development environment in their premises nowadays, because buying GPUs from the cloud is always costly. But when it comes to production, many companies do not have a choice. They need to get the GPUs most of the time from the cloud. Otherwise, they have to build their own infrastructure and data center, or which is again a complicated process. But when it comes to the development, they can always rely on internal servers. They can have a room where, right, a server room or something where they maintain big machines that can manage the load that the developer require to do their development activities and stuff. So these are some methods to avoid the cost or keep the cost minimum.
And the last question from my side, like, see, now every cloud like GCP and AWS, any cloud platform, so they integrated the DevOps practices. Like same way, the MLOps practices also will be implemented in every of the cloud in coming years. Like they
Actually,
have their own
I mean,
models. Yeah. Okay.
right. Actually, yes, there are services available that actually let you do the model development in a seamless manner. Like AWS has SageMaker, Google have Vertex AI. Now, these are different technologies that one can rely on to do the development in the cloud. You can develop a machine learning model in the cloud using various services provided by the cloud provider. So there are services available today, and that makes people's life much easy to manage. But one disadvantage would be, I mean, it could be costly when it comes to you want to do some testing or verifications, or running your code continuously on a computer would be costly. So I'm expecting that cost would come down over time, like as the new, like now there are lots of research happening in the data center side, GPU sides, and everything, computing side. So it is expected to come down in a few years or maybe, right? So yeah, so there are services available already in the cloud that help a developer develop the machine learning models and automate most of the operational stuff in the cloud itself.
And what I'm thinking is like, see, for example, if there is one model which is provided by any of the services, and that model is already trained with the basic data. Like, for example, in any sector, it may be, as we discussed, there is a basic structure and basic data structure for that. So if it is got developed from the services side, the rest of the data can be trained by the whoever is taking the service, the client, maybe whoever the end user it is, will be taking the service. So he will be training that particular model. So I think this will get happen in future also. Like, so the models can be get sold out and then they can train according to their company or requirement. So these models, I think this kind of services will be get implemented in the near future. As per this episode, I got understand and is the same thing that will be going on in the future side.
There would be a big evolution that's going to happen. I mean, it's the need of today for most of the companies. So I'm expecting a lot of new technologies, a lot of open source technology is going to come to the market and everything. Yeah, let's
So,
see.
so,
Let's
so,
wait and see how it evolves.
so, so, it, yeah, thank you so much for this episode, brother. And next time we'll see with a few more other questions and a little more deep into it. Okay. Thank you so much. Have a nice
Awesome, brother. Yeah. Have a nice